3, you're live.
Listen, why don't you hear your little thing?
Oh,
About Linux news and all that kind of stuff. Do you want me to do that? All right, fine.
Sure, go ahead.
Hey, everybody. Welcome to the February OLUG meeting. That's John, everyone else. Hey, so tonight's meeting, we're going to be talking about Fuse. Does anybody have any announcements or anything like that?
I got a question.
What's your question, sir?
Is it Fuse related?
No.
Then bugger off.
The question is moot.
No.
Question is moved to me. No, I have a question. Who's used KVM?
You ever use QEMU?
No.
Oh, well, I was going to say it's just like that, except it's much faster.
I've got the opportunity. I'm replacing servers in my office, and the scale computing guys came in and pitched, and they use KVM for their system, and I never touched it before. So I was thinking, hey, if somebody knows something about KVM and QEMU, I would love to hear something on this.
It's very nice. It's Red Hat's preferred solution. There's other ones. Zen, of course, is SUSE was their preferred one, and it's also what Oracle uses with their stuff. But at KVM, the main problem I have with Oracle's, with Red Hat's KVM solution initially was, if you actually deployed it, you needed a Windows box to actually do full control. They've since resolved that issue. Are you doing KVM on top of just on top of their Scalix system?
It's called Scale Computing, and it's hyper-converged system, and they use KVM as their management platform for their system. I mean, they've got some proprietary stuff underneath to do all of the hyper-converged stuff.
Yeah.
But
a little known thing with VirtualBox, you can actually switch it to use KVM when you're running it in a desktop.
It's not as cool as LXD, but
Right.
I guess from a personal standpoint, I'd like to learn. I'd like to see what the
I've got several boxes next door to me.
What's that?
I have like 3 or 4 boxes next door to me.
So, since we're looking for some items.
Oh, topics.
That topic would be a good one. Personally, I want to learn more.
yes. But you have 28 days.
Let me put that on the additional list. Well, and I don't want anything to fall behind. That's the reason I'm asking about searching.
But no, the KVM stuff's actually cool. I mean, some of the stuff, the other one that's really kind of interesting to me right now is LXD, which is Ubuntu's lightweight virtualization Docker type engine. It's their spin-off of LXC, but it supports things like machine migration stuff, which LXC and Docker don't support natively right now, 100%. So there's some cool stuff coming down. But the KVM thing, I thought that, I don't know why Red Hat really went with it instead of Zen, except for the fact Zen got bought up by Citrix at the time, I think it was. So they said it was different.
I used a Zen server when I was at Miller.
Yeah.
Used it extensively. Platform choice, to be honest.
But yeah, it works quite well for SUSE. I mean, SUSE uses it. Amazon uses its most popular virtualization out there because that's what Amazon uses. I mean, they have a heavily modified version.
Yeah.
But I mean, if you use the tools like libvirt and stuff on top of it, you really won't notice that much difference. It's supposed to be pretty good. I haven't played with it for a while. I mean, I played when it was just coming out as just being a faster QEMU and stuff like that.
Well, when I was looking at hyperconverged stuff, I talked to 2 different companies, and when they gave me the prices, and I got up off the floor after passing out, it said hyperconverged, I'm done. Scale walked in, and they ended the same price as replacing just plain servers. And I'm like, that provides for an interesting element.
I think they also do some cool stuff. You want to look at what they're doing with Docker too. I think they're supporting Docker's native containers too, which is kind of where everything's going to go long term.
See, Nutanix stopped by and pitched, but I haven't seen the price.
They've slowed down the Ferrari. Got out.
I don't know. They can't be as high as SimpliVity.
Well, it comes down. It's a question of what you're looking for in terms of enterprise grade. Some of those guys, I mean, it's a custom rack, custom everything. I mean, the only reason InfiniBand doesn't suck on Linux nowadays is because of Oracle's contributions to it, because they use it for their Exadata. Because InfiniBand used to just be the worst in terms of stability and performance. It was like, well, this is really bad. And then, I mean, they spent some serious time and money making it work decently. So, but yeah, I mean, obviously just keep shopping around. But no, Scale guys, I've talked to them a couple times. They seem pretty decent.
Yeah, Scale. One of the things I found interesting with them, good or bad, is that they they pitch to small to medium-sized businesses. They won't touch large enterprises. Their stuff, I guess, goes to like 15 nodes, 16 nodes. I think. I can't remember which, but it's they don't scale like the others. And I don't know. They came in price-wise at a point. It's like, okay, you got my interest.
I could. Is this in dollars? Yes.
Yeah. Okay, now we're getting closer.
Yeah. Speaking of interesting things, anybody see what Oracle did this month?
No.
The latest and greatest thing. Does anybody run Oracle database out in the cloud? Okay, one of the wonders of Oracle is they have a core multiplier. As you know, more and more machines are getting more and more cores. It used to be every 2 cores on Intel counted as 1 CPU. Well, they fixed that. Now every 1 core counts as 1 CPU. So they effectively doubled their price for running an AWS. I don't know how this is going to affect their RDS and stuff like that, because they've also done some machinations with their Oracle Standard Edition 2 pricing and stuff, the number of cores and limits. Because back in the day, Oracle Standard Edition 1 was phenomenal. You can buy it and run it on 40, 50, however many cores you wanted to, and it was just really nice. But they fixed that hole. So
So they doubled the price. We're happy.
Even with hyper-threading, it still flags that as an extra CPU core.
Yep.
Yeah.
I believe it's with hyperthreading, but they go by per core. I don't think they do the hyperthreading, but I mean, it's however they count. I don't think that that Amazon tells you what the core count is, though, either.
No, they
They give
don't.
it back out that way. They don't tell you it's hyperthreaded, because hyperthreading still is kind of a lame thing. Oh, it works all right for I/O bound stuff for the most part. Because hyperthreading, if you don't know what that is, that's just CPU pretends to be 2 CPUs. Whenever it goes from I/O wait state, it flips to another process context. So it's like a free core. They did it for a long time, and it was one of the things that Linux, when they actually got it in there, saw they're expecting like, oh, we'll see this kind of performance increase. It's not this kind of performance increase, but it was still free additional.
I remember the early days always had issues with hyper-threading.
Yes. Well,
Like,
we
we'll
turned it off on all our
and
Windows. We turned it off on all the Windows boxes. The place I worked for the longest time, because it just didn't work.
Yeah.
But with some of the stuff we have, but I mean, it's working now. But it goes back to the point. There's so many cores coming out now. Do they really need hyper-threading anymore? But still.
I know the processes I'm looking at. I'm looking at 18 and 20 core prompts
Yeah.
for these new servers.
Yeah. If you're another thing,
What are
keep.
you doing?
I'm taking 7 physical servers that are Hyper-V servers and condensing them down into 3. So I need to maintain my core
Yeah.
count of those 7 servers.
But keep in mind also that gets you back into potential licensing issues as well, depending on how they license per core. What's licensed per core? If you're running Microsoft SQL Server on it, you have to license the whole thing, or does it support the soft partitioning? Because the only partitioning that Oracle will accept is Oracle Zen partitioning for it. And that can be a pain in the butt. I mean, Hyper-V, that Microsoft usually accepts their stuff, locking it down per core, but the way it goes by some software, they want you to license the entire rack. And it's like, well, that just took that from $20,000 to $200,000.
The nice thing about being in a nonprofit is nonprofit pricing through TechSoup. So I'll be putting Microsoft Data Center on all 3 of these servers so I can load as many OSs as I need.
Excellent.
And yeah, instead of paying what's $20,000
Yeah.
for each copy, it's like $600.
That's separate from the KVM stuff.
Yes. Well, see, that's the interesting piece. I may not be able to buy a data center if I do scale. I may have to still license the OS, each OS. But yeah, because the way that the licensing reads for data center is Microsoft Data Center has to be your hypervisor to have unlimited OSs under it.
Yes.
So, yeah, interesting things you learn.
Interesting.
Reading licensing agreements.
Yeah. That's when you send it to your legal team and you don't sign anything. That's the most important thing.
I'm not allowed to sign anything.
Yeah, because I got to say, if it comes down to it, I'm going to be a witness for whoever is not going to get me in trouble. That's my company else. I don't get paid enough to go to jail. I am too pretty for jail.
Like I tell people when I do my speech every month to new employees, because I'm the HIPAA security officer. I don't look good in an orange jumpsuit. It does nothing to bring out my eyes.
Yeah. Okay. I think that's about it.
It's a
410.
good transition.
Yeah. Speaking with Linux, 410 kernel is supposed to be coming out in a couple of weeks here. If anyone, let's pretty kind of interested to see how that's going. It's depending, whether or not it comes out in the next week or two, depends upon how productive Torvalds can be in an airport, because he's apparently traveling, he's gonna try and get it finished during that and stuff. But, so, Fuse file systems. One very interesting thing came out today that's semi-related but not directly related. Microsoft released their new virtual file system, Git VFS, which is a Git virtual file system running on top of Git, which I don't know what they're using for yet, because I haven't seen the code for if they're going to release any of it. What it does, because right now the Microsoft Git repo is 300 megabyte plus, and if to sync it all takes many, many hours. So what they're doing now is they're actually creating it so it just creates a top layer that's independent, that's visible, then it just pulls and caches stuff as you use it. So if you're working on Word, it'll just get the Word stuff over time. If you're working on this, it'll get that stuff over time. And it kind of plays into a little bit what we're talking about here, because virtual file systems have some real value to them, and we'll talk a bit more about this. The ones we're going to be looking at tonight are both ones I've built for some forensic stuff I've done in the past. So we're going to take a look there. So it is the February 2017 OLUG meeting. I am me. Hello, me.
Hi, me.
Are you sure?
What is Fuse? I'm 90% sure. Fuse is a file system in user space, which is a very convoluted algorithm thing to get to. At least I didn't try and put more stuff in it to get to it like most of them. Simply, it is a way for users to be able to create file systems without having to do kernel work. If you ever try to actually write your own file system at the kernel level, going through VFS and all that stuff, that way lies madness. Because you can write a file system that in the system, I mean, at the VFS level, and it'll work. I mean, it'll be 5,000-10,000 lines of code probably. But to take care of all the edge conditions, race condition, this condition, that condition, that's where your life gets a lot more interesting. And that's one of the things that Fuse just takes all that away. It's all magically happy. One other, yeah, it's all magic. Another nice thing about Fuse is you don't have to be root to use it. You just have to be in the Fuse user group. So if you're in the Fuse user group of your system, you can mount and unmount systems. How do you unmount a system? Because I can't use unmount without sudo. Well, there's a fuser-l command which will unlock and unmount the file system. I hardly ever use that because I have root on all the machines, so I just sudo and just unmount because I just want to keep track of it. There's a ton of examples of Fuse file systems. How many of you have used a Fuse file system sometime in the past? Really? What? Okay. Let me throw some examples. You ever use SSHFS?
Yes.
I don't know what those letters mean together.
SSH? Know that.
Yeah.
Secure shell?
I think I'm more illiterate than that.
All right, secure shell is just the replacement for telnet and all that stuff. You SSH to any Linux box remotely, pretty much. You're gonna Linode or whatever. What SSHFS is, it's a file system that runs over SSH. It allows you to mount a remote file system via SSH. So you don't have to have Samba set up, NFS set up, any of that stuff. All you need is a log into a file system. You can mount it. So you can mount your home directory on your Linode system to your local system, or vice versa for that matter, if you have it set up to go out.
But how, with file locking and all of that other stuff?
Fuse.
Magic.
FM, got it.
Yeah. It's, keep in mind, well, that brings up a very important part about Fuse. And it's mentioned in the slides later. Is Fuse a production system? Would you run if your life depended on it, or if somebody you even kind of likes life dependent upon it, would you run Fuse as your production thing? Probably not. But for small one-offs and stuff like that, it is phenomenal. But SSHFS, I've used in the past for doing this. I used it the last time I was dealing with the Nebraska web server to mount stuff, so it looked like it was local, so I could just rsync the stuff through. I could rsync through SSH too, but I was playing around with some stuff. Okay. But that one is very nice. Gmail FS, this is one of the first ones. It was a very cool idea, because back in the days, many, many months ago.
G Drive?
Yeah, well, no, Gmail. Back when Gmail had 1 gig of space, that was phenomenal. You did not get 1 gig from anybody. So what this guy did, and he was a genius, or she, I believe it was a he though, he wrote a file system that runs on top of Gmail. So every time you make a file, it just goes out and puts it out there, and the file system puts a little freaking name on it, so it knows how to pull it back and stuff like that. It just creates a subfolder and just does all this stuff, and it's just phenomenal. So it's a file system. You can mount it, you can ls it, you can dir it, you can.
Yeah, we used a Mozilla plugin that enabled all that. So we were doing file transfers for my job before AIM.
There was a before
to transfer files.
The long time ago.
Yeah.
Sounds like a
The
really
dark-
roundabout way of doing things.
It is, but at the time it was phenomenal. The fact you could sometimes
This was before Dropbox, before
Yeah.
Google Drive. This was.
Yeah.
I remember when somebody started.
Was it before an FTP?
it was before you had a FTP server with 1 gig of space available for free. Back in the day, that was big. But Gmail FS is still out there, still exists, and it has its own thing. ZFS, if you don't know what ZFS is the most amazing file system that's ever been made. So honestly, it's tremendous. It can do everything BetterFS does. It can do everything that ext3 does, 4 does, 2 does, Riser does, all of this stuff. It is phenomenal. It's created by some and put into Solaris. It lets you do things, snapshots, all the stuff you want to do with a file system. And it has this wonderful problem. It's under a different license than the GPL. It's under one called the CDDL. Is not compatible with the GPL. If you get it, the latest version of Ubuntu, you can install ZFS and it's available as part of it. But there's a question about the legality of that. The Ubuntu guys say they have gotten it resolved. They've talked to Moglin, formerly from the Free Software Foundation, and he's said it's clear. And if you talk to Stallman will say it's heresy, they're bad people, and all that stuff. But there's been no legal resolution of it, because I mean, what he wants Oracle to relicense under the GPL, and they're not going to. So what somebody did, another brilliant person did, is they decided to take ZFS and put it in user space. So they did it all through Fuse, so you can mount a ZFS file system, do all sorts of magical things, snapshots, all this kind of stuff. Not all of it, but a good chunk of it. And you could actually read and write stuff. It's like, wow, that's impressive. And pretty much useless, because it's not something you want to, because ZFS is an enterprise-ready file system. The last thing I do with enterprise-ready file system is add a layer of shaking it. You don't want to Jenga it. This is what we're looking at here. But the fact of what it could do, that it was able to actually do this level of stuff, they're actually able to mount that kind of stuff on there, is phenomenal. If you look at Fuse file systems, there's a bunch more out there as well. We'll talk about a few more here, though. ROFS is the read-only file system. This is the simplest file system you can pretty much have. All it does is read-only. My stuff is based upon it for the most part because it is a very nice one. Because when you're playing around forensics tools, the last thing you want to do is have something that's going to theoretically write to the file system. But it gives you a core idea about how big you need to be able to write a file system. Because my two examples, one's like 600 lines, the other one's like 167 lines. That's all the more code I needed to write 2 file systems. And they both do some interesting stuff. But that one's a really good one to play with the exam to figure out how it goes. The MP3FS, another great idea. So if you...
What? MP3FS?
Yes. This is where it gets good. If you record all your music in FLAC, you can then mount that FLAC drive and pull stuff off, and it'll convert it to MP3 dynamically for you. So you can have all your stuff as FLAC, and
But
just
when you go
convert
to
it.
access it, it'll convert it for you. On the
Yes,
fly.
automatically, because if you have a lot of files, a lot of things, a lot of tools and stuff won't support that. But it handles it on the fly. Another very nice example. ZipFS. It's a file system dynamically and zips files from a zip archive. It looks like it's free to you. I mean, so you can just dynamically do it. You can mount all sorts of different ones on there. It's supporting additional ones all the time. There are
But only unzip.
unzip only. Yeah, it's read only. The ones that people do, the right ones, are the ones that are the brave people. Because I like Fuse, but the right side of it, I've done some stuff with it, but I'm still always a little cautious about it. One of the Python file systems I did do the writes, and it seemed to work pretty well, but I was always kind of concerned about it. But there are tons and tons of other file systems out there as well. If not, you can always write your own, of course. But it can do almost it. If whatever stupid thing you want, more than likely somebody else has already said, hey, I'd like that stupid thing. So take a look at theirs and see how theirs works first, is how I'd go. There's some more systems based on Fuse. There's Expand Drive. It's commercial software based on Fuse, multiple backends. It works on Windows and a couple other different systems, Mac OS and stuff like that. It'll write to S3, Amazon Cloud Drive, all that kind of stuff. And it just on the Windows side, it mounts on your drive, and it just can drag and drop stuff to it, and it's all magic. GlusterFS, Cluster Distributed Database file system for Gluster, which scales to petabytes of data. Once again, a very interesting concept. The Gluster stuff is built into the OS level from Red Hat and stuff is what I tend to go with, but if you do need to access this kind of stuff, it can be very useful. FS, the encrypting file system that runs on top of it as well. There's the Duke file system. There's a bunch of different ones. This is all kind of based upon the ideas from GNU Herd, because they had a versioning, translating type stuff for their file systems, and this kind of got brought into this. So it's very cool stuff. Interfaces for Fuse. There are a lot of different ways you can talk to Fuse. You can talk to it through Ruby, Objective-C, Python, Perl, C, C++, Java, Go, and others. And whatever the language, I did not find a fourth implementation, but other than that, pretty much everything else is there. There's also the ability to talk to it through .NET, so you can do F#, all that kind of stuff as well. Writing interface isn't that difficult. There's a bunch of them for Python, Python Fuse, Python LL Fuse, Python Fuse. I use PyFuse because that one seems to work the most consistently and compiles the best when you're doing pip installs of it. But for the most part, all you do is you have to write bindings for whatever goofy language you're using that go to the C libraries. It's not too bad to do. Because the Fuse has been in the kernel since 2.6.11, I think.
Yeah.
So it's been there for quite a while.
At least since 2013, according to what I'm looking at.
OS availability, Fuse is available on Linux, BSD, and Mac OS X. There was a Windows port, depending on who you talk to. It currently appears to be dormant, but you can use Fuse under Windows using Cygwin. So layers and the layers with wheels with
It's Inception.
Yes, I was thinking Doom, but it's Inception.
It'd certainly be nice if it was resurrected with the way that Bash can be on Windows now.
Yeah. I imagine it probably is. Well, I don't know
the tool chain.
Yeah. The tool chain's been updated to 16.10, but I don't know if it's got enough capabilities to do that because they just map out only certain calls. I don't know if we use that one though. They are able to see some of the stuff.
OLUG?
This is Linux user group.
Yes.
Yeah. Grab a
Come
chair,
on in.
man. So, so most Windows people nowadays are using a library called Dokkan, which is similar to Fuse. It does kind of similar things, but no one really knows. There's also another one out there which is kind of cool, which is called Windows WinFSP, which is the Windows file system proxy. It's similar concept to Fuse, but it's not compatible with Fuse. But the core concept carried over. It's like read a file, write a file. If you know what you're doing, you should be able to do a decent job translating between them. The core point being, it's available for a lot of OSs. I mean, it's also available for GNU Herd if you're really into that. But it's a little different than that thing. But it comes down to it's available for almost everything you need, so you can play around with it. The thing about it is it provides capabilities that you can't get anywhere else if you want to do experimentation with file systems, because doing it the hard way is literally the hard way. So I've got two demo file systems we're going to talk about tonight. One is called NewerFS. This is a simple read-only file system. It allows you to easily find out when files change in a file system. One of the tricks you'll end up doing if you end up doing forensics is, if you want to find out what's going on in a running system, is you'll do something along the following. Touch temp now. So now I've created a file out in temp now that's just this point. So if I go to my file system now and I do touch week 6 cloud, let's say, I can do find/type f newer /temp now /print. What this does is it'll do a find of this file system on the way down, looking for anything that's a file that's newer than the temp now file, which I just touched the week 06 cloud 01 DDP and printed out. So what we should see, and we better see, is just one file. Except for Google Chrome, which will always update for you, because you know why? Because Google Chrome hates me at times. So that's a very simple command. You'll run that a lot when you're doing forensics, or if you're doing a capture the flag contest, that kind of stuff. You want to know what's changing on the file system. You always want to know that stuff. You can do so. This is just using mtime. You can also use this for other components like access time and creation time. Of course, how many people actually mount their file systems with no A time on? Okay, just me. Because normally that's one of the performance things you'll always see. It's like, oh, my system's running slow. Are you mounting your drives with access time on? Yes. Turn A time off, because that will speed stuff up. Because every time you actually access it, it generates a log. So that in itself is interesting. And Let me make sure I got this right. So I have a program called NewRFS. Let me Control++ this a little bit for you guys.
Thank you.
NewRFS.c is 609 lines of code. It compiles, it's under GPL version 2, supposedly. No one really cares because it's not being used by anybody for anything. So to compile it, it just is the link with the LFuse, the main program, and you're on your way. But this one just, all it does is we mount the file system, NewRFS, the original file system, and where we're mounting it to. And we also pass the parameter saying what file we want to compare it to. So for that, it'll be the equivalent. Now, it'll be a little simpler when we explain it out. But so let me show you how debug prints is stuff I should have taken out. But it's got things like it translates a path, because one of the things it has to do is it has to translate the path from your virtual file system to the underlying file system. What this does is it just gets that information out. But other than that, it's all just callbacks. So if there's a get attribute, find out what the attribute is, return it, you're on your way. A read link, just do a read link on the translated path. Very simple. So the thing is, once you use a framework, you'll have all these callbacks you need to fill in. And once you fill them in, you have a fused file system. You can pretty much compile without that beforehand, but whenever you go to one of these things, you're going to error out. An example being, let me show you read dir, pretty straightforward. Oops, static buffer, that's bad, that's me. This is my part of it, because it'll look by access time, C time, M time, so on and so forth. Make note, here's an example of one of the things. This is not supported on a read-only file system. So what do you do here? You ignore the parameters, void path, void mode, void rdev, and return arrow fs. And all it does is it says it's an error. So the point being, the program doesn't crash. It actually returns an error code that is interpreted up through the file system, is actually passed up to it correctly. So it'll actually know, it'll actually show up permission denied, that kind of information. So it actually handles it smoothly, which is very nice.
So take care of your conditions.
Yes. So you're taking care of all the basics on this.
Mm-hmm.
So make dir the same way, unlinks the same way, arm dir. Keep in mind, this is a read-only file system, but only because I'm telling this read-only file system. There's nothing in here that's preventing someone from theoretically taking the program, compiling a debugger to it, and making calls out to this stuff. It doesn't have that level of restriction. It's just all at this level of the program. But no, it's just a bunch of callbacks or the thing that if I were to just put a couple of voids and stuff in here, done a base case in C++, I could probably cut this down to much, much less in terms of stuff. So here's the way it works through the callbacks. So it's just C, but it looks a little C++s because it's all based on callbacks. Use the statement, which I didn't update all the way through. And the fuse, all it does is goes through and parse it. And just a simple main that just passes it with these parameters. So for this 600 lines, I now have a file system. And if I do NewRFS, home, Grothe, fuse, home, Grothe, MNT, minus O, M time, temp, what was I called it now, I think?
Yeah.
Okay. So now, if I look in this file system, I look in the right file system, I mount it under mount. First off, let's do this real quick. We do a df-h. There's a file system, home Grothe mount. And if I go into home Grothe mount, there will be directories because the directories have to exist. I chose to have them exist because there could be files all the way down underneath it. But if I go over here, and let's say, if I could type, things would be better. Pi. So now we come back here, we should see the HashFS pi file and the A and the B pi, because those dates are newer than they are under the original file system. So what I've done now is I've automated the equivalence of the find command for me. So anything I do like this will show up in this variation. Is it useful? It actually has been pretty useful in some of the capture the flag contests I've run in. because it provides a simple way to just keep going, seeing it all the time. Because now the thing about it is I can use all the commands. I can tar this information off. I can theoretically stack another file system on top as I want to. I can put the log file system on it to see what's actually changed between versions and stuff. We'll show an example a little bit later when we show the stack file system. That's actually pretty cool. So what have I done here? Create a real simple file system that has one piece of functionality, but it's the one piece of functionality I wanted for this. So, yay me. So that gives you an idea that's how simple it can be to write one. There's nothing to this. This is an amount of code that it took me about a day and a half to write it, mostly because I was reading the wrong manuals and doing some stuff not correctly. Didn't spend enough time on it. But no, I have it mounted. Now if I want to unmount it, I'll just sudo umount. And everything showed up right. No errors, nothing got thrown off here. All the logging is all based in the core of it. So nothing bad happens. So we're all right. Does anybody have any questions about how the base core of that works? Okay, excellent. So, actually, and the other system we're going to talk about is HashFS, which is one that's another read-only one. It dynamically creates a hash file MD5 extension for each file in the file system, which has got a bug in it I've got to figure out, but it's good enough for tonight. Let me talk a little bit more about this because I overstepped my slides. I hadn't looked at these in a month because I wrote it a month ago. NewerFS, C interface, 609 lines of code. Pretty straightforward. It's about as simple as it gets. So we saw a quick demo of that. Let's take a look at HashFS. This is written using the Python fuse bindings. It's 167 lines of code. Again, there's a lot of room for improvement. So let's take a look at the code real quick for that bad boy.
The fewer lines of code, is it because you're doing less or because you're using?
It does more, actually. It's because of Python.
So it's because you're using Python rather than C.
Yeah, but that's kind of a false equivalency because I don't have brackets and stuff. It's all, it does some stuff in less lines of code, but it's also because of the way in Python you use the indentation. Meanwhile, C, I have to use brackets left and right, and I overspaced it. Okay. I mean, lines of code isn't perfect.
So instead of being about 4 times as big, maybe twice as big?
Yeah, I'll show you the HFS pie here real quick. So, what this does is, one thing it does, this one does it actually does take a little bit more time, is it actually does the MD5 sums, which I could update this to support anything I want to, SHA, Tiger, Whirlpool, whatever I want to do. But it comes down, you'll see there's some similarities here. There's full path, which is equivalent to translate path. There's access, which is the same as some of the other ones, some of the other ones in the standpoint of accessing it. Chmod, own, get attribute. Which this one I've got it faked out because what I'm doing here is for every file in the file system that I'm mounting under there, I'm creating a shadow file called MD5. And that file doesn't exist except inside this file system. What it does is it returns lies to the upper file system. So there's a file called .md5, and we'll see that in a minute. So what it does here is you can do any translation you want to. I can change the names of it. I can create a file that's 16 terabytes in size that takes 1 byte on my machine right now, just based on how it's laid out. So there's no real restriction on what you can do it. You can do anything you want to with the translations and stuff. But you'll see there's read dir, read link, make node, which in the same situation, since it's a read-only file system, what this does is it raises a fuse error. StatFS, which is a little bit ugly code. I guess I'm not proud. It's not my proudest code, but it goes over the same basic thing. So what we've created here is a very simple file system. And it's just, we have a main, we do the fuse, it's just phenomenal. It works pretty well. So let's run this bad boy. It's also, it's right now I'm doing it in Python 2. I also work under Python 3 as well. Home Grothe fuse, home Grothe mounts.
You gotta do HashFS, don't you?
You actually have to put, yeah, I was gonna say, I was seeing it would catch that. All right, so one thing about this is the other one went into the background automatically because it was compiled as a daemon program. This thing does not, it stays active. And once I control C this, that file system goes away. You can use the daemon tools and slow that to background without any problems. But from the standpoint of what I was doing, this works pretty well. So let's control plus it one more time. And now if we go over to do a DF, we see a mount file system again, like before. We go into it, and we'll see there's a whole bunch of files called MD5. So every file system that exists that has a decent name, yeah, with fake ones. Now if we go to vi newer.text.md5, what am I doing? Something's off. This is the bug I see. Is every now and then it'll have crap at the end because I've got a race condition in it, which goes back to the concept. Does this happen under the C file system? No, but the Python has a little tiny bug. But now, here's the funny part. So now if I get out of this and I go back into it, it doesn't have that. Why? I don't know. I really don't. If I knew. So what can I do in this situation? I can always have to do a cut. I can do something else with it. Or I can wait a couple seconds while the file system kind of stabilizes. If I do a find throughout the file system, it will somehow synchronize everything. I think it's a bug with PyFuse. If I was actually going to try and use this for important stuff, I would probably look at the other file system or possibly go down the whole, how many of you guys use pip? Pip is part of the Python wonderment. It's equivalent of CPAN. And pip is also...
thing I use Python for is to run the printer software and the 3D printer.
Very good.
I don't know anything about Python. I tried to learn it and lost interest.
It's actually a pretty decent language in a lot of respects. One of the things that makes it very powerful is pip, because it has the whole file system. The problem with pip is if you end up doing things like one of the programs I recently wrote used the OpenPy Excel to convert it to read Excel spreadsheets and stuff. And that turned into a whole going forward and backwards until I found the right version of pip. Because until I found the right package that would actually work the way it was supposed to. Because sometimes people check it in and it doesn't work on your system. It might work on somebody else's system, but it doesn't do you any good. So there's a little bit of back and forth on that, especially if you're starting to do things like doing a CX freeze or something like that and creating an executable out of it. You can run into these kind of problems because sometimes it's not all in sync. But it works, which is the important thing. So now we have a whole load of files here. And if we do a find, like that, minus name, MD5, that's all the file system because it sees it actually comes back with those. And we do an ls-l, what's it say the size of those files are? It says it's the same as the original file. And why does it do that, Aaron? Because Aaron was lazy. Because Aaron started trying to figure out, do I want to put 16 here, do this and there? It's like, wait, I've already statted that file. I'll just copy that to the other one. And everyone's happy. So, very cool little thing here. Does this work? It works pretty well for what I was looking to do with it, which was just go through a file system, do a find, pull all the values across, so doing out the exact MD5. Because one thing to keep in mind is, doing this with Fuse this way, this is one program running. This is one process space. If I do the find and exec out to MD5 all the time, that can be a lot of additional overhead. Which if you're doing a bunch of file systems looking for horrible stuff that you want to find out about MD5, check something against the list you already have, it can be quite useful to have that. So,
if you run du on that folder, does it honor it, or does it kind of wig out? Okay. Interesting.
yes. But you want to, in this situation, if you see something wigged out, all you got to do is, of course, the basic, which is this is just amount of the other file, the Fuse file system. Let's and that's my presentation. So it's always time to, that's the great thing about tabs, man. I remember the days I used to not have tabs. Those are bad days. So what do I get here versus here? not so good, but actually that's is the way I'm lying to the system. It's better if I were to spend more time on it.
But that's all part about the troubleshooting is
Yeah.
running the commands and figuring out what it's doing.
But the thing about it is I could run the command without it like boom, blowing up on me and causing horrible, horrible damage to everyone around me. So that gives you one idea of what you can do. So I got 2 file systems here, each one that filled the need I had, that was able to help me with my job and do stuff I wanted to do, which is cool. Worked pretty well for me. But let's take a look at something a little more interesting. And here's where life gets a little bit more weird. So either one of these could be written using the other file system. There's nothing that's newer that's doing that HashFS couldn't do, vice versa. The only thing is if I was to do HashFS in the using the C libraries, I'd have to have a library for hashing stuff. So I'd need to use like librhash or something like that, which Python makes that quite a bit shorter because that's a built-in library command. But I could do it all. It's nothing that you couldn't work around it with. So there's nothing unique either one that says this one has to do this one has to do this. But it works pretty well. Here's where things take a turn for the more interesting. One of the capabilities of Fuse file systems is you can stack them on top of each other. So, due to the way I've designed HashFS, I can't stack it on top of newer FS. I have to do it the other way around if I wanted to do it, just the way they're laid out in terms of writing the files underneath and lying to each other. So, let's see how this works. First off, we got to make a new mount point. Let's starting with the basics. CD make dir mount 2, and now we should be able to. And I do say the word should because I do not. I tried this several times, had it working quite well, and it's been a little bit since then. That's why it came back to 0, because this is your only file. That makes sense. New RFS, home, Grothe, mount, home, Grothe, mount 2, minus O, M time, temp, now.
You need a space in there?
Nope.
Okay.
I actually, the way I wrote it, I actually had to rediscover that last night because I was putting a space in there, but it was small. So now, if we do a DF, what do we have? We have 2 file systems mounted. And if we go into mount 2,
One says pass through.
but if we touch temp now, they're all disappeared again because the newer file system exists in there. But if I touch one of them again to get it back, by touching the Fuse file system, now I will see 2 files. I better see 2 files. Yes, I see 2 files. I see HashFS pi, and I see the HashFS pi MD5, which is dynamically generated. And if I take a look at that HashFS pi MD5, it's going to be a pain and give me the wrong value. I know it's going to do that garbage thing at the end. And no, it won't.
Are you sure it's not like the amount of time?
It's something to do with, it's a race condition that seems to be possible. I think the fact that Fuse, it may actually be fixed by running it through the C interface because that does a different, because that's synchronized.
If you're doing it with folders that are larger and larger in terms of content.
No, these are next to nothing in size. It's something to do with it doesn't somehow synchronize when it opens that file, so you're getting a block of crap. So where that block of crap comes from, I don't know, but it could be interesting stuff in there. But that gives you an idea what it can do. So what I've done is I've stacked 2. So theoretically, you can put Gmail, SSHFS, NFS, ZipFS, all of these on top of each other until you reach a certain point. Right now, internally, I think it's set to, the kernel set to allow with like 32 or 16 files, Fuse file systems at any given time. Why would you want to go that deep? Because you're a masochist.
Go deeper.
And here's where it gets interesting, though. If you start mixing and matching things like, would you mount multiple reads on top of each other? Sure. Would you mount multiple writes on top of each other? That's where life gets a little more interesting because you've got to make sure everything works. And if there is a bug or a timing thing or anything like that, then you're still talking potential issues. But that gives you an idea of what it can do. Yeah, actually, I gotta say, Fuse has always worked out pretty well for me because I use it for just these minor type things.
Yeah, I've used it. It's worked pretty good.
Yeah, I mean, I was using it for SSHFS between my server and my desktop machine for a while there, but every now and then it would just lose the connection. That would somehow have problems. But keep in mind also, there is a possibility if you unmount a file system enough times, you will run into something in the kernel and it will just go bleh. Now, it won't die, but it won't let you mount that file, use that point anymore. Like a home Grothe mount, that would become unusable, but it wouldn't show up why. It's a bug, but I can't get it to the reproducible state because I was going to turn it into the kernel mailing list. Sorry.
So for SSHFS, normally for SSH, there's options for you to set so that your session doesn't time out.
Yes, you can use, a lot of people use with that is auto SSH, which will automatically reestablish connection. But I've run into problems in the past, I don't know, something just fritzes a little bit. Okay. I don't know if it's something with running in my system in terms of components or not. But it can do, what it can do for you though, is if you have a system with limited access to it, all you have is SSH to it, you can actually mount a file system, do a DU, do finds, do all that kind of information on it. So, I can't believe both my demos actually worked. This is like the first time in a long time I've had good demo luck, which means, of course, I probably just screwed myself for Infotech.
You can do this one for Infotech?
No, we're doing, Adam and I are going to do a whole day workshop on cloud.
Oh, that's right.
It's going to be phenomenal. If you haven't signed up for Infotech yet, you should look into it because it's going to be phenomenal this year. There's going to be this really great, Adam and I are going to do this tremendous day of cloud stuff, which is going to be us doing implementations of programs in Amazon, Google's cloud, Azure, and a couple other ones like that. We're still working on it, but it's actually looking pretty decent. So, challenge of the Fuse. You always got to put the challenges in there. Speed. Keep in mind, you are not going to be getting full file system speed because you're running a file system on top of a underlying file system and bringing your data into user space as well. Which every time you do user space stuff, it does tend to put overhead on stuff. Is it worth it? Oh yeah, it's definitely worth it for me as opposed to trying to write a real file system and do this kind of crap. But you are taking something in there. Every time you do that, you are doing a miniature context, which you are potentially turning yourself over to schedule and all that kind of stuff. And you're doing IO wait type stuff. Stability can be a bit fickle, especially if your file system has a bug in it, which I can guarantee you on that.
So do you know of any situations where they've exposed the bugs and then fixed them because they found them through freeze?
I don't know.
I'm sure that's probably.
Yeah, I'm sure it has. I'm sure it's used. If I was going to create a new file system, I know the guys who do BetterFS, they have an implementation of a lot of their stuff in Fuse, and they test a lot of their ideas and stuff in there because it's like we said, it's
rapid development.
It takes stuff a lot better. But after a certain number of mounts, your Fuse may go into a weird state. It can be in the hundreds of mounts and unmounts. Gives you an idea how in the world my preparation for the demo went. So it can be very hard to reproduce on demand, and it didn't clear up until I rebooted the thing. Writing to the file system can be risky if your code has a bug in it. That's always the case. Just think about you're taking responsibility for this. Another Fuse file system I didn't talk about was WebDAV, which actually is a pretty cool one as well, which does all that. Is Fuse production ready? No, I don't use it in production. I do know some people who use it in production. They're braver than I am, or stupider. I don't know which it is. Probably a combination.
It's like almost like I haven't talked to them in a while. Are they still alive?
I don't know. They still are. It's this guys at a small company, which I understood why they used it because they needed it to do certain things with it, and they used not Fuse they didn't have their own custom version of it. They were using the built-in utilities like SSHFS and stuff the way they did the distribution of stuff. But really, quite simply, Fuse is a tool that allows me to do very cool things with file systems, ideally without needing a root, which is a tremendous thing to keep in mind because on a lot of systems you're not going to get root. So the ability to actually be able to mount a file system, to be able to do stuff with it, to be able to actually experiment with stuff, be very nice. Because if you are doing something like at the university, they do their operating system class. If you want to figure out how a file system works, there's no better way than actually writing as an operating system, writing a file system on top of it, and figuring out how those components work and stuff like that. It works pretty well. What can Fuse do for you? Ability to create a custom file system. You've seen two tonight. It's not that tough. Here's an example of one of the ones I thought was kind of interesting. You want a file system that copies everything to a remote machine when it is written, or just moves all the files to a hidden trash folder, deleting them. You can do that. One of the cool file systems I didn't talk about is LogFS. What that does is it just keeps track every time somebody opens a file. But if you combine that with a versioning system, there can be some very cool stuff there in terms of forensics, capture the flag contests, that kind of stuff. You can use it to create custom tools for forensics, which I do know several people who do that because it is kind of cool stuff. If you have an idea for a file system and you think that, hey, you know what Linux really needs is VMS style file names of the systems of all their things. Because if you ever used to use VMS, it would always put a semicolon and then a version number at the end of your file. They keep the last 3 versions. And you think, that is so stupid until you blow away a file. You're thinking like, man, that's actually kind of cool. So if you want that, you're more than welcome to write that. You can write that component. And to write it just using the Python side or something like that, if you're a student or something, is probably not that much stuff. But if you look at what's happening with that, another one that needs to be written now is somebody needs to write a Linux version of Git VFS. I don't know who's going to do it. There's already a Git file system that will mount your Git and bring the stuff over, but I don't believe it is smart enough to do just the relevant files. I think it pulls everything. But if somebody could do that, that would be kind of cool too. So, but yeah, if you want to experiment, prototype a file system, you can prove out your concept without even write a lot of hard code. There's a lot of hard code to a file system.
Interesting from a honeypot perspective.
There's quite a bit of capability there too. Do you need to write a fuse? Probably not. There are hundreds, if not thousands of them out there. Before you write anything, I'd go do a search in DuckDuckGo or Google if you still haven't given into the fact that Google is evil and you can't just give them whatever they want. I am. Unless my resume gets accepted to Google, in which case everything is fine.
Yeah.
But I mean, it comes down to take a look at what they can do. More than likely, a lot of them out there. There's a lot of them that still have active maintainers doing it. If you have something you need, you can actually ask the guy. There's been several people who have added components to things like ZipFS and stuff like that. So it just recently added ZXTAR support in there, something like that. Pi file system. This is not Fuse, but it's Fuse-like. It's another system written in Python that only provides some similar capabilities. It is more true to the Python way, but it only works with Python, so keep that in mind. You can't use the other stuff on it. But it already supports a lot of file systems: WebDAV, FTP, FTPFS, S3FS, Tahoe, LAFS, and Zip. Because everybody loves Tahoe. It's the file system of yesterday. But if you don't Python, you want to write a file system, you don't want to go through the whole Fuse thing. But the Fuse thing is very cool because it covers all the capabilities and stuff like that. So that's all I got. Anybody got any questions? All right.
I asked them in the middle of your presentation.
That's no problem.
It was very cool.
So the links, I've got them. I'll throw you the slide deck if you want to go to the website. But it was Fuse, ROFS, WinFSP, Python, PyFile system. That's it for me, man.
Awesome.
Interesting, there's a MooseFS.
What does MooseFS do?
MooseFS is a distributed fault-tolerant file system available on every OS with a Fuse implementation. Able to store petabytes of data spread over several servers, visible as one resource. I just like the name.
Moose.
Moose.
Maybe their Theodore Roosevelt came or developed it. And they were thinking of bull boots.
You still have to use sudo.
Well, I could do it using fuser.
Well, they could be just Canadian.
I could do it using fuser-l, but I'm just, you know.
Tried and true.
Oh, the problem is like every time I do that, I didn't want to show I couldn't type the command right the first time, so I did the sudo raw instead. So. All right, well, cool. March is 28 days away, so it'll be March 15th. We'll be back down here again, right?
Yep.
And the topic will be something.
That's correct. It'll be something.
All right. Well, cool. Thanks, everyone.
Good night.